Hey, Walter.
Hey, how's it going?
Good. Should we wait for Professor or just we can start?
Well, I can ask a couple questions about GitHub actually, because I've never used it for like.
I'll try my best to answer them. I've just created the account the other day, so I was just learning about it as well.
Gotcha. Yeah, I did a tiny bit in like high school, but we never really like used it for programming. We just like got some files from it, that's all.
Mhm.
Um, but yeah, I've never really used the whole like push and pull for programming. So we'll see how that goes.
Mhm. Yeah, so the way I have the file set up is if you remember from the quest, the splay tree was divided into two files
Hmm.
because for the quest we worked on the binary search tree first, and then we added the splay header file. So I just merged those two, and then I got rid of some functions that I don't think we would need.
Perfect. Yeah. Yeah, so I remember when he was talking about the thing, he was talking about how we need to make sure they're both like close to each other in terms of like efficiency, like we shouldn't have, random checks and unnecessary things.
Mhm.
So I think I'm not sure what he'll say, but I'm guessing that's sort of maybe the first step, just making sure the AVL and Splay are like, similar to each other and how they're set up.
Mhm.
Um, so I guess that's definitely something we can work on.
Yeah, I think
Also,
they do share the rotation functions for a start. So I believe
right,
those are the same in both trees.
right.
Recording in progress.
Hi, Professor.
Hey,
Hi.
yeah, hey, yeah, good morning. And yeah, but it feels like there was a week's break, but actually it was just last week, right? You wrapped up your two, yeah, it feels to me like there was a week's break. Maybe because I'm just used to the, spring break. When does a spring break happen? Spring break happens before spring quarter, right? Between the winter and spring quarters. Yeah, not between the spring and summer. Um, well, that's cool. That's really cool. So, all right. So here and congratulations for finishing to C. Um, uh, is it recording? Well, it is recording. Okay. So yeah, I think historically. Just taking the 2C students, not all of the students I've taught since questing began, which doesn't include 1A, because just the C++ track, but just 2C alone, the ones who enrolled in 2C, less than 5% of them usually have in the past completed Quest 9. What I mean by that, so well, less than 2% have aced Quest 9, and, well, basically aced all the quests. Less than 5% have completed Quest 9, and and the reason for that is really that you can pass the course, right? I mean, from after you finish 6, you've passed, and after that, whatever you do just makes it better and better. You grade better and better. So technically, you don't need to do Quest 9 completely to pass. So I'm very happy to see both of you have crossed that final milestone. That's absolutely fantastic. And it's even nicer because you went through 2B and 2C. Because one of the other metrics I look at is how many of my students in 2A started questing blue in 2A and then went on to complete red 9. So which means they've done all of the quests in their respective quarters, because I'm not counting the 2C students who had to do blue and green also, like you guys. I'm thinking about students who started in blue and then didn't give up and then did green and then did red also. I think that's less than 1%. Less than 1%. That is the smallest fraction I've ever got of all of the numbers. So hopefully that I don't know. I don't know how much longer I'll be teaching this, but hopefully, if that number improves in the next few quarters, that'd be cool to see. Anyway, I shouldn't be rambling. This is basically your meeting. So here's what I'm saying. Okay, the way this plays out. No, if this is your first project, first thing working together, or even first publication and things like that, I know from my personal experience it always feels more secure and better. It feels better the more people you have in the team. And but in practice, after you manage teams, you realize that is not the case at all. In fact, every single successful product out there was actually built to a certain stage when it started having momentum of its own by one person. Not even a consortium of people, not even two people thinking together, right? One person usually has an idea, maybe another person also working on their own, and they maybe converge. But I've seen every idea I've seen or heard about, they've all started off in the minds of one person, and basically, so, but in this case, both of you have had this idea and been working on it. So I think it's okay to have this confluence, and then the two of you basically author this paper and do the bulk of the, actually all of the work really. In fact, I shouldn't even be, looking at your code early on. You should be reviewing each other's code. And then if the numbers don't, if the numbers don't make sense, okay, if the numbers you generate don't make sense, then I'd be, intrigued enough to look in your code early, right? So I'll say, hey, why the hell is this going on? Something is like wonky here. So then otherwise I would basically, the numbers say, well, if the numbers make sense, I would say, I'll reserve my option to look at your code until the very last moment, just before it goes live and all. I can take a look to see, here's how you can polish it up, insert a comment there and things like that. I can make those things. Until then, you don't even have to share it on GitHub. Just share it on, I don't know, is it free for private repos on GitHub?
Yeah, it's free.
Wow, I thought you had to pay $5. Yeah, that's why I didn't use private repos in those days.
Oh, actually, no. It's it might be for private ones. This one's public. I figured no one would find it unless we actually like.
No. Even private. No, to see if private repos are free, because I think I told my son one time that I'm not using. He wanted to use Git, and I said I'm not going to use Git because it's $5. And he said, no, last year they made it free for everyone, even private repos. But I didn't know how to, I didn't know how much weight to attach to what he said, but check it out. Okay, if you can make it private to Walter until, until such time as you're ready to go live with it. And then I can look it over too. And really, you don't need to go live with it until your tech report goes out. And when you have a link in the tech report saying, here's a source code, you can check it out, right? So
yeah,
then
no one would find it.
No, people will find it. I mean, people, when this paper shows up in their LinkedIn feed, for example, right? So they're going to go and Google and, and provided the Google spider has been there, on the GitHub page. Because, in one of my CS2A lectures, I asked Google, how do you recognize speech? Well, actually, technically, I didn't ask it how do you recognize speech. I asked Google, how did you rec a nice beach? And obviously, intentionally, and Google recognized that as how do you recognize speech? But the interesting thing about this conversation, that conversation that I remember now, is that instead of just giving me a blurb of information, it actually started reading out the GitHub source code that Agnes, one of my students, picked up and said, wow, Google is reading out the entire source code C++ program on, and that happened on the Google device. And so I'm pretty sure that once your paper is out there on Stack Overflow, which I'm pretty sure Google crawls on a minutely basis, it'll probably link directly from there to your GitHub repo, and someone could be sitting on their chair or sofa or ask read me Rayleigh's hey Google, read me Riley's Riley and Walter's source code, and from GitHub repo, here's your code. Okay, so here's where so the other thing so the overall plan, it's so straightforward. You guys could basically take, I think you'll be going full speed. You just need to be careful to slow down, I think, because this will be very tempting and, make you. So one of you should create a Google document. Both of you comfortable with Google Docs?
Yeah.
Great. Okay. So one of you, actually, let me see if I can get gallery, because I can't get, Walter is not. Okay. Now I can see all three of you. Great. All two of you. So both of you, and me, all three of us. Walter, are you comfortable with Google Docs? Oh, Riley, you didn't have the Gmail address until Walter forwarded it to me. So I didn't have your Gmail address. Are you comfortable with Google Docs?
Yeah, I've used them.
All right. So let's just, one of you should create a Google Doc. Call it some temporary title for now. Tech report, CS2Z, whatever you want to call it, and share it with both me and Riley, and Walter. Whoever creates it shares it with the other two, and we'll use that as a template for the paper going forward. And when I have a moment tomorrow morning, I think tomorrow morning, I'll try and flesh it out the sections that you have to fill in with, maybe headings. You can change everything in the paper, including the headings and everything, right? But I'll just put the headings there that you need to flesh in and say, this is where a graph needs to go. That's where a number needs to go. This is the experiment where, you're doing, and so on and so forth. Okay, that's all. And I think, and then because it's in Google Docs, everything is going to be version. So anyone can change anything at any point. When one of us wakes up in the morning and says some drastic changes happen, sees some drastic changes happen to the paper, they can always check with the rest of us and say, hey, and one of us says, hey, I didn't intend to make that change, it was accidental. You can always go back and say, make this the most recent version. All those things are, versioning of the document is available for free, so I think we can take advantage of that. So this is the paper. We can put it together in a couple of days once we have the template and when we start generating numbers. This is the plan for what I'm thinking about right now, and we can see how far we can go with this. So because just doing splay and AVL, I think you guys will get it done in a couple of days. I think we can make it slightly more interesting. Okay, so you can say we're going to take 3 different data structures, or 3 different, 2 data structures in an algorithm, or whatever it is, right? 3 things in computer science that are often tested on uniformly distributed numbers. Now we're going to see that if the same results that are published in benchmarks, which are generated from uniformly distributed, which presumably are because we don't know, right? Presumably are generated from uniformly distributed numbers, match up with our own uniform distribution or our own Gaussian distribution, right? We should choose Gaussian other than exponential and all these other funny things, because most of the natural distributions are Gaussian, right? Because once you sum up multiple distributions, you get a Gaussian in that range, right? The central limit theorem. So here's one of the things that one of you can do, or both of you can do. Look up what we'll do to generate a Gaussian is, let's just add 5 or 10 invocations of RAND, right? RAND is guaranteed to be uniform. RAND, will be uniform. So 5 or 10 invocations of RAND and average the number. So, add 10 invocations to RAND and divide by 10. Now that number will be a Gaussian, because the central limit theorem, actually, you'll be surprised, you only need to add 3 and you already get a very nice bell shape. Only 3 rands, but we're doing 10. So I think what we can do is, if you Google somewhere, or you do a little bit of research, I don't know, Wikipedia, math Wolfram or something like that, we just need to find out what is the equation of the Gaussian that approximates the distribution obtained from summing 10 uniform randoms, or n uniform randoms, right? Or k, whatever, some constant number of uniform randoms. So we just want to, and I'm pretty sure some student somewhere would have solved it, and it's probably published in some ancient paper even. So you just need to pick up the equation and say, we're using like 10 Gaussians, and this is the random distribution we're getting. We just need to say that because in practice, we're just going to do the 10 randoms and divide by 10. But, and then in our paper, in your paper, I shouldn't say our paper. When I say our, I mean, Bergstrom and Short, okay? So in your paper, when you say add, this is how we're generating the Gaussian number. So you have the algorithmic distribution, the description there. This is the algorithm we're using. RAND plus RAND plus RAND plus RAND divided by 10. That's a method for getting our, right? However, where is that number coming from? And it's not sufficient to just give the algorithmic distribution. It'll be nicer if you also give the equational distribution of the normal, which that Gaussian, which you see in the histogram, approximates. So whatever you can, you get 3. If you get the average of 3 you're still going to get a Gaussian, but it'll be more approximate to the true Gaussian. So the more randoms you add and divide, the average of the greater number of randoms, you get more and more of a Gaussian. So if you add an infinite number of randoms, you get a true Gaussian. That is what the central limit theorem is. Yeah, so we're saying, we're not going to go an infinite number of randoms. In fact, if you go to the math library and say how many terms are used to calculate the e to the power, e to the x or something like that, I'm pretty sure it's not, I don't know, maybe 10 terms, right? Because in Blue Quest 5, people see, just with 5 terms you get so accurate expressions. Just with depends on the math series that you pick, right? Some terms, some series converge faster than others. So anyway. So that is the overall framework. So I'm thinking, so we're going to look at the effect of the two different kinds of distributed, differently distributed inputs to the system. We'll figure out how the controls are done and how to make sure the exact same numbers and later on, right? That's all a piece of cake. It's like a half a lecture, a quarter of a lecture in 10 minutes time of our discussion. So we'll leave that to later. But the overall plan is that. Right. So there are two streams, two different distributions, and we will feed it to AVL versus splay, right? AVL does and uniform Gaussian. We can have these numbers and compare and make some interesting observations there. And number two, we can say now we want to test the same thing, same kind of thing on hash tables. One of them is a lazy chain, whatever that thing was, a chain hash table, and the other one is going to be a quadratic probe hash table. And you can even use linear probing, right? So you can say linear probing, quadratic probing versus, and it's going to be a real test, and it's an empirical test. And you say, and so you can have that kind of comparison. I'm pretty sure you can get it to go, right? And in fact, if you've done a quadratic probing by hash table, a chain hash table is a half-hour work for a half-hour job for you, really, isn't it? All you need to do is just stick a link to nodes into the hash value. That's all, right? So it's a half hour. So you can easily do that, and you use the STL list because that's what everybody will use, and it's easy for them to reproduce your things. So you can do. So already you have 2 of those things you can do, right? 2, 1 and 2 is trees and hash tables with the 2 different distributions, and you can do a third one, just icing on the cake, for the win. You can say we're going to test sorting. Okay, so you can use 3 different sorts. One of them is actually what I'm going to call a hybrid sort. By hybrid, I mean the standard library sort. Okay, standard library sort, many people think is actually a quick sort all the way, but it's not turtled all the way down. I think because the standard library sort, if you have noticed in quest number 7, is actually slower than the sort that you implemented. So something weird is going on. I haven't looked into the details. Maybe the partitioning scheme, right? Maybe we got one cycle better than the published thing in the Hoare algorithm, or maybe the standard library sort is using an inefficient partitioning, like Lomuto or something like that, even, right? Or even even more likely is that what usually happens is that the standard library sort is they've done things cleverly, sometimes too cleverly, I think. They say, a quadratic, the quadratic Q sort on average, right, the parabola is going to intersect the line at some point. Yes. So when it intersects the line, the Q sort is going to be slower than insertion sort. So at that point, I'll switch to insertion sort. So who knows when, what the threshold is that they're picking to say at that point, I'm not going to do Q sort anymore. I'm going to do insertion for the rest of the way. So, turtles all the way up to here. From here, it's elephants, right? So who knows what the hell is going on with the standard library sort? Whereas what you've done, for sure, there's turtles all the way down. Okay, so you can say, 3 different sorts. One is you can basically, and for shell sort, I think just use a standard shell sort, having the distance, not, using any of those fancy, jump sequences. Yeah, because, fancy sequences, that's a field of research on its own. Yes, because if you say this, so we'll just say, shell sort. And shell sort is very easy for you because if you've done initial insertion sort, shell sort is easy, really, isn't it? And it's actually provably faster too. A lot of people say, well, can you prove that shell sort is faster? Of course it's faster, right? Because in insertion sort, if you look at the number of comparisons, the number of swaps you have to do, right? You have to go from anything to go from n to m, it has to do m minus n swaps. There's no way you can go from here to there directly. And we know for sure that in the sorting algorithm as described, no inversion is, no non-inversion is unrectified, meaning you don't, if there's if there are two numbers in the right order, you don't make that an inversion and then rectify the inversion, right? If there are two numbers in the right order, you leave them alone. So, obviously, if you have to do that, rectify that many inversions, and in shell sort, you actually skip that. If you go into the right place, you actually do. So you save cycles there, right? By not rectifying inversions that you otherwise have to do an insertion sort. So all of these things, but you can do a shell sort, insertion sort, shell sort, forget about insertion, right? Shell sort with, the having thing, that's quite easy. If you get to it, it doesn't matter. Even just those two data structures is fine, because shell sort is already an algorithm, right? Because you can say two data structures. That itself is a paper. But for icing, if you have time, you can also say, well, two data structures, we also did sorting as an algorithm. And we can say sorting, actually does better with, a quick sort all the way on this kind of distribution, which you expect in nature versus, stuff that isn't, uniformly distributed, which really hard to get. As my two A students are discovering, it is actually, I don't know, it's hard to get uniformly distributed numbers, and that is the value of RAM. Anyway, so that's what I'm thinking, and so that is the overall plan for the paper. And I would say the way to get started is one of you do AVL, or both of you do AVL, and exchange code and review each other's code. Okay, and try and squeeze out cycles and say, make sure, and just make sure correctness first, efficiency next, right? And then when you look at the results, you'll know if you're already on the right path, I think. So and use that website. I think it was Mitchell. Mitchell posted that visualization thing.
Oh yeah,
So
I have it linked as well in the on the GitHub on the CPP file.
Great. Okay, I'm pretty sure there must be a lot of sites like that too. So you can
That's I think there's definitely a few. I think that's the most extensive one I've found. It's got like a ton of data structures.
Great. Okay. All right. So use that to make sure your transformations are okay. In fact, what you can do is this is what I would do is rather than come up with test cases too soon, because a lot of times we come up with test cases, but the best time to come up with test cases is after you've exhausted the free pictures you get in your textbook, right? Open any textbook and they'll say after left rotation, this configuration changes to that. Yes, just a zillion pictures like that. Just recreate that configuration and you can take it for granted, right? If it's a reputable site, that's what's going to happen. Just make sure you get the same transformation, right? When you have all the things that you see can work, then you can craft your test cases to do random things and then cache the corner cases. That way you'll have much better luck, even crafting test cases, just to make sure that, the most obvious gotchas, you can leverage other people's knowledge and say, they've got that picture up there because someone ran into that problem. So maybe, we can just, write on their back. So get those out of the way for AVL and splay. And once you got the results for AVL and splay, as you're working on the paper, filling in the numbers and paragraphs and restyling things and so on. And then that time you can say, well, I've got a lot of typing and interesting thing here, but I want to feel like coding. Then you can code the hash table. There's not a lot of coding with hash table. It's just a matter of coming up with the test cases and in your main to see, this is how we're going to compare numbers. I think it'll be a very interesting set of empirical comparisons. I haven't seen any one source where they've actually done an explicit comparison just dedicated to this and to just the data structures only. So it'll be nice. And I think it may even be valuable for a number of people. So let's, hope for the best. Even if nothing happens, I think it will be a very interesting experience for both of you. Yeah, and I'm pretty sure it will be valuable also. So I'm glad. I'm actually very glad to see, you guys not only completed 2C, but you're still interested and moving forward and so on. And once you've got the first thing out of the way, the next one you can say, well, there's another idea we want to work on. Maybe other people can also join now, right? So you can, but before you get, here's the best way to build team members later is to already start working with them a little bit. And so just get familiar with their working style and also coding style, because you may have really kick-ass coders. They don't have the same working style, right? Or even the same hours, or, something is out of the, right? So they could be different, good, productive in their own teams, but not together. So those are things you can only discover by actually working together. And saying, well, it's really cool, but it's better if we work in different teams and then share the results rather than work together and share source code. So how will you discover those things? And it's better to work informally together first. That is why in also the bigger companies, they err on the side of familiarity with working style and collegiality more than expert knowledge. Because expert knowledge, it's much easier to train people, or even if it's a very top quality person who is hard to work with, you can always say, I will give you a silo and you can work there and we'll take your results and apply it. Yeah. And that won't be possible for others. So anyway, so that is my 2 cents. And I'm very happy to see you work on this. And I hope that, this will be valuable for not only you, for also future students who can see this and say, well, there's something we can aim for now. Maybe, get a tech report like those 2 guys, it's spring 22 or something like that. Do you have any questions? So to do, in terms of to do, creating a Google Doc, don't have to feel rushed or hurried about this, okay? Add your time. I have some time tomorrow. Most of the time I have time, okay? So whenever you're done, before you finish up with all of the experiments, just do a Google Doc and share it with me. It'll only take a day or max a couple of days to get the paper together. Usually getting the meat of the paper together is harder than writing it down, especially since I'd also help you get the paper as tight and precise as possible. Okay, so too many papers out there, there's too much waffle in them, unnecessary stuff. We're talking about a scientific paper. We should talk about the method, the results, and what we're doing and what we're shooting for. Right? And we should just keep all of the fluff to 0, right? If not a minimum, no acknowledgements, even if, forget the citations, right? Do away with the citation. Who cares about the citation? I don't even read the citation in it. Because if I see something and I think that doesn't sound right, this takes me less time to just Google it and, find more information than to look at the reference number and go for the paper. Yes. So, fuck the citations. So just keep everything to bare minimum and just trust the reader's good sense to see that, that's what they're saying. Let me just Google and find out if that's true, right? And then it's going to be online. So if they disagree with you, there's no point in going to a library and looking at the journal and publishing a paper anymore, or a critique anymore. They can just go to Stack Overflow or wherever the paper is published and just make a comment saying, hey, that doesn't check out. I did an experiment. Why doesn't? Because these are things that you normally see in a you send it to a journal, right? And you do some experiments. And sometimes you get a comment back from a referee. And what do you, well, you don't, maybe you have relatives who've seen that, right? And the referee would say, hey, interesting paper, but, unfortunately, your experiments seem to be wrong because I did the same thing and I get different numbers. Okay, I've had that experience happen to me. Okay, as a student, when I thought I had a revolutionary result, and I published something, and a referee report came back and say, here's what, why my result, explain why my result is different from yours, and I couldn't explain it, and in fact, I found an error in my own paper. So that is the value of a peer review, But the thing is, these days, peer review is I don't believe in it, right? In fact, I don't look at, the whole thing is down the drain as far as I am concerned, because when I read a paper these days, when I read anything on Wikipedia, if things don't make sense, you can always you can always look it up and convince yourself. So we can just minimize everything, and you don't have to say anything. And though that person could now, if I had a choice, for example, right, I wouldn't have sent it to the journal. I would just put it online, because because with the journal, it's a real pain, because sometimes you have to wait for 6 months, sometimes even a year before you hear back from a referee, and say, and by the time you lost interest in the paper, and and we're not talking about 40-year-old people there. We're talking about students like you, right? And for them, time is passing really, really fast. And 1 year, you have to wait for a year before you hear back on an experiment that you did. That is a piece of shit, isn't it? It's not even relevant to you anymore, because your life is moving so fast at that time. And so if I had a choice, I would not have sent it to that shitty journal. I would just put it online. And if someone had something bad to say, that experiment is a total piece of trash, I'll be delighted to know so that I can fix it sooner than have to wait for 1 year before I can fix my shitty experiment. Yes? Because that's how students think. That's how I thought. And that's how I still think. I don't want to wait. And that year was a real pain for me. And if I was going to be disabused of my erroneous notions, I would rather it happen sooner than later, right? Especially since I was willing to be corrected or told that I was wrong, right? So those are the things that you have the luxury of, of experiencing these days. So just eschew the old method and say, this is a paper, this is a tech report, right? There's no citations here, no references. Anything you want to know, just ask in right here, because this is the paper, right? And see how it goes. It could just be revolutionary to the whole field, even, because even now, even as we speak, the people are trusting publications less and less. And I see even on Facebook, some of my, past friends and colleagues, they're complaining about publications, Ken Church or whoever, right? He's complaining about ACL all the time, saying, oh, there's a problem with referees. And, this, and referees are not qualified to review the papers themselves anyway. And these are all these issues that have been plaguing academia for a long time, right? And the funny thing is, I was not qualified to review a lot of papers that were sent to me when I was, an academic. And I would not get papers that I was qualified to review for. It was very slim, actually, because when you're a student, you can only review like 0.0001% of the spectrum or less. But you never get papers sent in that area. But if you do need to get a paper out in a journal, you need to also serve as a review for someone else. And what are the chances? So I never get, and so a lot of reviewers are incompetent, which people like Ken are picking up, right? And well, they've been, people have been complaining about it for a long time. But a revolution like you guys could make, your generation could actually create, will actually change the face in how scholarly information is changed, is shared. And I think people are getting less and less reluctant these days, or hesitant to share their work, because go online, the younger people they're just sharing everything out they produce, right? They don't have any they don't feel embarrassed that if someone is going to go and say that's wrong, right? People are sharing, right? That's what I see. It's everything, everything is turning out to be like, it's just like a Fortnite game, right? I go, I play, I lose, that's okay. What the hell, I can play another game. And and you just keep getting it better and better, and you have fun in it, and that's really what makes the difference at the end of the day. And so I'm actually very happy in that sense about the gaming culture and all these things that have come out of this, is that there's less reluctance. Maybe it's not because of that, or just the internet, right? And the fact that you can be out there, is that people are just coming out of their shells and saying, why wait these days when I can just be out there and get instant feedback, right? And there's no stigma attached to things, or less stigma attached to many things these days because of information sharing. So that's really cool. I don't know, might be wrong there. So anyway, that's the overall plan. And I think this will actually shape up to be really nice. So can you guys basically take it from here? You can always call me any day that you want another meeting, just like this. Let me know. We'll just set up a Zoom meeting. I think I can just go now to Zoom and say, duplicate this meeting, right? Any other time. Doesn't have to be Monday, right? And once you've got a little bit of momentum, you can also say, we want to invite more people to just come and act as observers, or we even participate in the discussions. That's fine too. But I think everybody should know there's not going to be any acknowledgements, not even to me, okay? You shouldn't waste any words in the paper saying, hey, thanks to Professor Anand, or, discussions in CS2C. That's all a piece of shit, okay? Serves no purpose. Nobody's really interested in these things. All you want to say is, this is the experiment. This is the thing that we're thinking about. This is what we tested. These are the interesting numbers. Or is this cool or what? Okay, that's really what you want to say. Okay, so we'll just keep everything to that, very precise and tight, and you can put it out there, and everybody should know. And we're the only two people who are doing the experiment, because any more than that, it doesn't, we don't need more people to do something so simple, right? When you identify a bigger task, then you say, we need more people, and people are willing, Yeah, that's what I think. Okay, if you think that you need more help, you can let me know. You can invite more people. But I think based on experience, my review of work that you guys have done so far, this is many more people will start feeling bored. Okay, so I think this is already too little work for the two of you. So you should just try and make it stretch. Maybe fill it in with all the text that you're going to write in the paper and so on. But this will be enough work for you for at least a couple of weeks. Okay. After that, we'll see what we can do. Right. And if you guys are interested in, gaming, we'll see if we can come up with a project in gaming, or if you have time, we'll see what we can do after that. Is that okay? Are you guys happy with the plan? Can you guys take it over?
Sounds good. Mhm.
Fantastic. Right. If you have any questions, you can ask me. Otherwise, feel free to, or you can just talk and then, let me know when you're ready to go. You can talk as usual, right? I can turn the laptop around and I can go, and you can let me know when to stop the recording.
Sure.
Any questions for me?
Not yet. I think we'll probably call on you in the next few days, probably to help out or.
Yeah, no worries.
Yeah,
No worries. Take
yeah.
your time. No hurry. Okay, we're not in the 2C crunch now. Okay, no hurry. Take your time. Even if this paper or this tech report takes you many weeks, that's okay with me, right? I'm just teaching 2A and 2B this summer, and some of the students are, like you guys, they're very keen. And yeah, actually, I was reading a 2A post halfway before I had to start this meeting, and they're all making interesting posts now. So it's probably, due to the culture that you guys have created. So it's very nice. Thanks. All right.
So the splay tree is done. Or at least it should be. I just want to test it to make sure I didn't accidentally delete some major function. I don't think so, though. So I'll test that later today. And then we have the insert and remove functions on the AVL tree. And,
Right.
I've been reading into the AVL trees because I didn't get a big chance to do that during the quarter. And I think we only need one more variable for the node class, or the node struct in the class. And I think that would be the weight or the height, but I'll have to do some more reading into that.
Yeah, it looks like, I'm trying to look, for the AVL class you already have, it already has a height
Oh,
image.
okay, yeah, I did have
Uh,
I don't think the constructor works for it though. Yeah, so I could probably change that.
in terms of your rotations, they look good. I recognize it because it looks similar to what I did, and I don't see any unnecessary checks. The only thing you check is for null pointers, so I think that's perfect as it is.
Yeah, one spot I think in the display tree actually that might need some going over is the display function. So I remember when I was writing that at the time, I just barely understood how to do it. So it might have some things. It could be more efficient, but I'll check that over as well.
Right.
Other than that, I think just that we'll work on getting both trees working, make sure they don't have any bugs in them, and then we can work on efficiency.
Okay. Yeah. Perfect. Trying to think. I'll probably need to do a bit more research just on the RAND and how to test for that and the timing and everything, just because we've never really tested for timing, only for whether or not it works so far. So I'll need to do a bit of research on that. And yeah, if you prefer, I don't know if you prefer email or anything else, but I can send you links to things I find useful or something like that.
Sure, yeah, email works for me, or if you find something more efficient, I'm down with anything.
Okay, perfect.
And then you can work on trying to figure out how to maybe pull from this repository. I know.
Oh yeah, I'll do that.
When you make a change to it, hopefully that'll work out smoothly. Just let me know if you have any issues with it.
Yeah, I should be able to figure that out today. And it seems like I'm a contributor, so I should already have everything in order to do it. Okay, yeah, perfect.
All right, so I think that's it then. I'll just do the make sure the splay tree works, and then I'll start on maybe the insert function for the AVL tree. Read more about that.
Okay. I can also look over my AVL, see if I can. I'm trying to. Do we? Hold on, I'm trying to find where the AVL.
Did we do? We didn't do an AVL tree in the, or maybe did you work on something outside of the class? I don't think we did an AVL tree.
I thought we did, but yeah, that might have been something I looked up myself. Um, but yeah, I'll look into it because I thought it did. So I'll see if I have any code for that, and if so, I can just well, hopefully then I'll know how to add to the file, so I'll just add it to it then. But yeah, that sounds good.
Sure. Okay. That's it then. Professor, I think we're good to go.
Okay, all right, thanks. All right, just send me an email whenever you guys are ready.
Okay. Sounds good.
All right, so I'll stop the recording right here. Bye.
You guys later.
Bye.